Greetings. This recording is proof to show empirical work done on guidelines for programmers on securing web application from SQL injection and cross-site scripting. To develop a fully functional web application was not the goal. The web application was developed to safely test the hacking techniques. The goal of the project is to prevent SQL injection and cross-site scripting on the back end of a web application and to provide guidelines to programmers in PHP and Python. With that said, let's get straight into it. This recording will only show SQL injection. One other recording will show cross-site scripting as well. To start off with a formal definition, the SQL injection attack occurs when a malicious user, through a specifically crafted input, causes a web application to generate and send a query that functions differently than the programmer intended. To put it out in simpler terms, SQL injection is a hacking technique used by the attacker to add SQL code to a web form input box in order to gain access to unauthorized resources or make changes to sensitive data. So we will be replicating the attack on a website, the SQL injection attack. The website is an e-commerce website with PayPal as the payment gateway. The goal is to secure the website from SQL injection. So we will start up with a manual injection. The login page was intentionally made with a vulnerability, so we will try to attack or inject this page and get access to the admin page, which is hidden. The attack that we will be using is a tautology attack and end-of-line attack. All the attacks are explained in detail in Matisse's report. So let us have a quick look at the DBMS and get started with the attack. So I'm sorry. So this is the DBMS and we are interested in the users table. The users table holds the admin accounts, which says username is Nickel and password is Nickel as well. So let's go check that out. So this is the website, the PHP one, and this happens to be the Python one, which is not fully developed. So that's how we are going to differentiate between the web applications. So we will go to the login page, and at first let's try something wrong, and it says please try again. So we could see there is some kind of validation going on here. So let's try the correct input, and it would okay. So it took us to the admin account, so where we could view products, delete them, add product, add categories, do all kinds of stuff. So let's perform a tautology attack, which says or 1 equal to 1, which is true at all times. So when we hit submit, so it took us to the admin account. So the code is pretty much weak. Let's try one other attack, the end of line comment attack. So it goes by or. So okay. So it says or get me the version of the database and comment the rest of the code. So I'm leaving the password field empty because it will comment the rest of the code, meaning the password validation would get commented out. So I don't have to bother about that, and I hit submit, boom. We're inside the admin account and the SQL injection is the user. So this web application has a vulnerability right now. So let's test the same thing with the PHP, the Python. So we Python website, and we try Nickel and Nickel. So when the details are right, it should take me to the home page. So it took me to the home page, and when they're just wrong, it should give me something like an error. Yeah, we get an error. So we say Nickel, and so the SQL injection works well on both websites, the PHP and the Python. So what are we doing next? So we will be using SQL map. So SQL map is an open source penetration testing tool that automates the process of detecting and exploiting SQL injection flaws and taking over database servers. So we will use SQL map to penetrate the web application. We'll also be using SQL map to evaluate our work, that is to see if the web application is safe from SQL injection. To give an overview of SQL map, SQL map is an open source penetration testing tool. They also claim to be the ultimate penetration tester, and this tool is used by hackers to do hacking stuff, very bad stuff. So it supports injection techniques, all 6 injection techniques as stated in my thesis report. So that's good. Now let's test this out. So we say, yeah. So the code to run SQL map. So let's break down this code. We call SQL map, then we feed it the URL. At this case, the URL for the PHP code is login.php, and we'll have to fill in the parameters so SQL map knows where exactly to inject. So we say username, password, and submit. And --dbs is we're telling SQL map to retrieve all database from the server. So let's quickly have a glance at that. So as you could see, there are 8 databases here. So we are asking SQL map to do the job for us. Retrieve all 8 databases. So we'll copy that. I'm sorry. Okay. So SQL map is running. Okay, that was very quick. So it has retrieved all 8 databases. So let's have a look into it. So it says parameter username is post. Let me zoom into that. So it says parameter username is post. The type of attack is boolean based blind, and the payload used is like all of that. So as you can see, it has used an end of line comment to leave the password and the rest of the field empty. So there were 3 attacks which were successful. So it also said username, payload username. This would also work, which is an error based and a time based blind attack would work on this vulnerability. Okay, now let's test out the Python. So Python is running on this local host with port 5000. We are performing the same attack. So it is also fetched 8 same databases. So the parameter was username, and a boolean based attack was used, and then we have the payload right here. So they are the almost identical payloads, and a time based blind. So PHP, the website on PHP and Python are both vulnerable right now. So let's secure this code. So how are we doing this? So this is the bad function that it was running on. Let's change this so it can prevent an SQL injection. So how are we gonna do this? Let's have a look at that first. So we are running SQL map. Okay, how are we gonna stop the attack? Layer 1 would be to sanitize. We could do the same using MySQL real escape string function, which will do this for us. And the second layer would be to create parameterized queries. Parameterized queries, otherwise called as prepare statement, is used to prepare/compile SQL queries and statements, and can be implemented to execute queries in a secure manner. PHP does this using PDOs, and Python does this using placeholders. So let's have a look into that. So here we have the save function. Let's take that out and comment the bad function out. Okay, let's break this down. So we are escaping the string, that would be layer 1 security. Then we prepare the SQL statement, then execute it, so the database knows exactly what SQL query to work on. So that is how we are going to secure this in PHP. So let's save that, and going back to the Python, we do the same. We encode or escape the input, then we prepare the statement, and in terms of Python we use placeholders to create parameterized queries. So we prepare the statement, then execute it. So this is the bad function. Let's take this out. And this function is safe. So save that. Let's go back to our website and test them out. So we go back to the login page and we try Nikhil or 1 = 1. So it says incorrect password. So how about we try the end of line comment attack, and it says user does not exist. So we have secured the web application in PHP. Let's try the Python one. So we go to login, we say Nikhil or 1 = 1, and we submit. It says error. So it says SQL injection is not working here. So how about we try or version attack here, and still gives me an error. So we've secured this. Now to evaluate our work, we will test them against SQL map. As you can see, SQL map has logged these datas. So let's delete them. So we've deleted that. Okay, let's run SQL map once again. So we say Python. So we're running the same code against the same page. So it's already saying might not be injectable. So we're trying other techniques. So it says password might not be injectable. So we're pretty much on the right track on securing the web application. So we've got the results. It says critical, all tested parameters do not appear to be injectable. So we've secured the PHP web application. Now let's check the Python web application. Yes. It also says critical, all tested parameters do not appear to be injectable. So we've secured the application in both PHP and Python. So how have we done this? We created layer 1, we sanitized, and layer 2 we created secure queries by parameterized queries. We could do more to this. So we've secured the application. So a hypothesis for SQL injection proposed are parameterized queries, stored procedures, input data type validation, customized error message, whitelist filtering, and configuration of DBMS. So we had a look into what parameterized queries was. A stored procedure works in the database. So we create a routine and we parameterize the SQL to be passed. So we basically are building strong SQL queries. So input data type validation is something else we have to do. Validating the request method, email passwords, checking for empty strings, all integers, booleans, whatnot. So packages can be used in Python, such as Flask request validator to do validation in Python. Customized error message, something like setting error reporting to 0 in PHP, and we could do the same in Python. Whitelist filtering, a simple whitelisting program which would whitelist, and we could also modify this to be a blacklist. So all good characters should be whitelist and the rest of the characters must be neglected. Configuration of DBM is giving the users the right privileges. And the summary to end this all, I would say secure coding practice must be followed in all languages. Never trust user generated data. Filter and validate all data. If neglected, will result in an SQL injection. Tools can be useful for testing for vulnerabilities. Vulnerabilities are often due to human errors. On testing between PHP and Python, I've come to a conclusion saying PHP should not be used for security critical applications. I've also mentioned this in my thesis report. And to summarize the attack with the instructions, I will leave that for you. Thank you. Stay home, stay safe.